So this is for 8.6. This is the last section in chapter 8. It's operations with vectors, just different kind of things you're going to do with vectors. So one thing you're going to see is you're given a vector mn with a terminal point like 9. This is m, sorry. The initial point 9, -8, and then terminal point -3, -1. And you want to find the component form of this. So finding the component form, all you do is x minus x and y minus y. That's all you do. X minus x, y minus y. And you take the second x. So let's do x2 minus x1, y2 minus y1. So x2 is -3 minus 9, so that's -12. And then -1 minus -8 for your y's, that would be 7. So component form is -12, 7. Then if you want the magnitude, that's the square root of x squared plus y squared. So you would just do the square root of 12 squared plus 7 squared. Now notice, I did not put the negative on the 12 because I'm going to square it down anyway, so it's not going to be there. So that would be 144 plus 49, which would give you the square root of 193. You have to simplify the radicals. This radical doesn't simplify, but if it does simplify, you need to simplify the radical on this, and that's what they'll ask for, okay? So do another one like that. You're looking for component form when you're given the vector KL, where K is 2, -7. That's your initial point, and then your terminal point is 6, -7. So again, to find your component form, you do x minus x, 6 minus 2. Again, it's terminal point minus initial point. So 6 minus 2, -7 minus -7. This would be 4, 0. So there's component form. And then you're asked to find the magnitude as well. So that would be the square root of 4 squared plus 0 squared, which would be the square root of 16, which would just be 4. That's the magnitude or the length of the vector. So they could ask you a couple of different ways to find that magnitude. So it's magnitude or length of the vector, okay? Then you're going to have to do operations with vectors, certain operations, multiplying, subtracting, addition, that kind of thing. So for example, you will want to do u plus w, and they give you u as 6, -5, and they give you w as -2, -3. So then u plus w, you just add your x's, which is 4, you add your y's, which is -8. That's all you do. Or you might have, if we had u minus w, so we're going to subtract them. So this is where you need to be careful. 6, -5 minus -2, -3. So that subtraction sign is going to change these signs. So this actually becomes 2, 3. So we'd have 8 and -2 for the new form. So be careful when you subtract, okay? Then you'll see something like this, absolute value of 3u minus absolute value of v. Absolute value is just the magnitude. It means the magnitude. And this means the magnitude, okay? So our u here on this one is 5, -2. And then our v here on this one is -5, 8. So this 3u means I need to multiply that by 3. So I need to do 3 times 5, -2. So I'd have 15, -6. Then my u is still just -5, 8. But I want the absolute value. Those are straight brackets, absolute value. So I've got to do magnitude. So 15 squared plus 6 squared, or square root of 15 squared plus 6 squared, minus square root of 5 squared plus 8 squared. So you're subtracting the magnitudes. So this first magnitude is the square root of 261. The second magnitude is the square root of 89. Square root of 89 doesn't simplify. The square root of 261 does. If you take 61 and break it up or divide it, let's see, 261, it's actually 9 and 29. So that's 3 and 3. So it would be 3 square roots of 29. Sorry, that is a 3. So it would wind up being 3 square roots of 29 minus 89. And you'd stop right there. It says to write an exact answer, so no decimals. So that's your exact answer. 3 square roots of 29 minus the square root of 89. And I kind of almost ran out of room. Okay, so there's that one. Then you'll have to calculate a couple of things. Oh, you'll see this. You'll see a V4 plus O, and our V still, oh no, V is -6, 7. So that O right there stands for the 0 vector. So it's just like adding 0 in vector form, but that's called a 0 vector. So you're basically just doing 4 times -6 times 7. So -24 and 28. And if you add 0 to that, it just stays -24 and -8 and 28. And that's your component form. You could also see something like absolute value of 3W minus V, where they're both an absolute value. So my W here is -1, -3. My V is -4, 7. So what you do here is you do all this first, and then once you subtract them, then you'd find the magnitude. The magnitude would be the last thing. The difference here is you did this and you had that. You found the magnitude first, and then you tried to subtract them, okay? So here we're going to do everything in here first and then find the magnitude. So that means 3 times -1, -3, minus that -4, 7. So this is -3 and a -9 there. Minus, which really, you know, that's going to change those signs and have it be a 4 and a -7. It's going to change those signs right there. So -3 and 4 is 1, -9 and -7 is -16, and then finding the magnitude, square root of 1 squared plus 16 squared, so square root of 257, which does not simplify any, so you'd leave it as a square root of 257. Okay, then you're asked to find U times V, which this is actually called a dot product. We're going to use a dot product here in just a minute when we find the angle between two vectors, but this is called the dot product. Dot product is very easy to find. You'll be given two vectors, like U is 3, -4, and V is -3, 4. To find the dot product, it's x1 times x2 plus y1 times y2. That's all you do. x1 times x2 plus y1 times y2. So I would do 3 times -3 plus -4 times 4. That'd be -9 plus -16, which would give me -25. That's all you do to find the dot product. So I don't need to show you another one of those. Then you want to find a unit vector with same direction. Now you're gonna be asked for a direction angle here in a minute, but this is just the same direction. So let's see, as the given vector. So my given vector is V, -3, 4. So we want to find a vector with the same direction. So what you're going to do is you're going to find the magnitude, which is your R, okay? Then you're going to put X over R and Y over R, which is your cosine and your sine, because here in just a minute, they're going to change from asking you to find a unit vector with the same direction and ask you to write out a unit vector with a cosine and sine, okay? So remember, you've got to do cosine and sine. It's X over R and Y over R. So you're going to find the magnitude first, which is R, and then you're going to write out your cosine and your sine, okay? So square root of 3 squared plus 4 squared, that's your magnitude, or you recognize it's a 3, 4, 5 pi trie, so this is 25, which is 5. So you would have -3 over 5 and 4 over 5, which would be your cosine and your sine, okay? But they have it, they want it in component form, but they'll have the pointed parentheses there for you. You just have to plug in the -3 over 5 and the 4 over 5. Okay, so let's try another one like that. Again, this is same direction. You want it same direction. Also could be asked for parallel. If it's the same direction, they're also considered parallel vectors. So on this one, my vector is -3, 6. So again, we want to write x over r and y over r. Or remember, that's the cosine, that's the sine, because we're going to use that here in a minute. So we got to find r, which is just like finding your magnitude. Magnitude and r are the same thing. They're the length of the vector. If you ask for length of vector, magnitude of vector, if you were asked to find r, it's all the same thing. Square root of 3 squared plus 6 squared. So that's the square root of, what, 9 and 36, 45, which simplifies to 3 square roots of 5, because it's 9 times 5, so it's 3 square roots of 5. So you would take your x, negative 3 over 3 square roots of 5, cancel the 3, so it's negative 1 over the square root of 5, which is how you leave it. You can leave it this way, okay? So that's considered your cosine. Here, it's just a parallel vector to the original vector. It has the same direction. And then you'd put 6 over 3 square roots of 5, not in the final answer. Y over r is 6 over 3 square roots of 5, which would give you 2 over the square root of 5. And it looks like the computer is allowing you to leave that square root in the denominator without you having to multiply top and bottom by the square root. Okay, so that's your sine. Again, we're going to talk more about that in a minute, but when it asks for the same direction, you leave it just like this. It'll give you 2 slots to fill in, and those are the 2 slots you fill in for the same direction. Okay, then that's all component form. That was all in component form. You know, the pointed parentheses, that's component form. So when you're given something in component form like 6 comma 5, you're given that in component form, you could write it as a linear combination. So sometimes they're going to ask you to write it as a linear combination, which is very easy. A linear combination is xi plus yj. So my x is 6, my y is 5j. Now that's not imaginary, okay? That's not an imaginary number. And also this can go on a graph. This is your I, this is your j, when you're going to graph it, because that's going to come up as well. But that's the linear combination. That's it. 6i plus 5j. That's it. So say we had, oh, I don't know, where's another one? I'll just make it, negative 4, 6. So a linear combination would be negative 4i plus 6j. That's it. That's how you write a linear combination when you're given component form. This is component form. This is linear combination with the ij. Okay? Let's do another one that's the same direction. Again, same direction. So I've got negative 5, 12. Same direction. This is where you find the magnitude, or r. This is r. So it'd be square root of 5 squared plus 12 squared, or you recognize that that is a pi trie, so your r is 13. So negative 5 over 13 and 12 over 13 is the vector with the same direction. And again, this is your cosine, this is your sine, because it was x over r and then y over r. Okay, so that cosine sine thing is going to come here in just a minute. Okay, so let's see. Let's look at some operation using linear combinations. So I've got u is 2i plus j, and v is I minus 7j. This is actually w, not v. U is 2i plus j. W is I minus 7j. These are linear combinations. So we're asked to find 3u minus 2w. So 3 times 2i plus j minus 2 times I minus 7j. Easy. It's easy. It's distributive. 6i plus 3j. Here you're actually distributing in a negative 2, so negative 2 plus 14j. Combine like terms, 4j, 4i, I wrote it correctly, said it wrong, plus 17j. Component form, 4 comma 17. So this is your linear combo. This is lin combo. And this is your component form. You're asked for both. You're asked for the linear combination and you're asked for component form. Okay? Let's try another one like that right quick. Let's see, I've got 4u plus 5w, where u is 2i plus j, and w is I minus 5j. So 4u plus 5w, u is 2i plus j, W is I minus 5j. So 4u, so 4 times 2I plus j plus 5 times I minus 5j. So 8I plus 4j plus 5I minus 25j. So 13I minus, what is that, 21j? If I didn't mess it up any. Okay, and so there's that, and then component form would be 13 minus 21. I don't think I missed anything on that because it's plus. I distributed correctly. Yeah, okay, so there's that. Then you're asked to sketch something like pi over 3. Which you need to remember that pi over 3, if I do 180 over pi, that's 60 degrees. So if I'm going to sketch it, it's going to be right here. And they may have a circle around it like they're putting it on the unit circle. So you've got to sketch that. So there's the sketch. And then you want the unit vector for the given direction angle. So we want the unit vector for this angle, which means we want the cosine and the sine. And it'll be in a linear combination. So it's going to be cosine I and sine j. Cosine will go with I, sine will go with j. So we just need to know the sine and cosine of 60. Well, we've talked about the sine and cosine of 60 a lot. The sine of 60 is, I always get these messed up. Hold on. Before I say it wrong. And they have to be exact, so I can type it in the calculator and see what it is. Square root of 3 over 2 is the sine of 60, and then 1/2 is the cosine of 60. If you ever forget, which this is the way I should have done it, remember your 30, 60, 90 degree triangles. Short side is 1, longer side is the square root of 3, and then hypotenuse. Sine is opposite over hypotenuse, square root of 3 over 2. Or y over r. This is y in this triangle, y over r, square root of 3 over 2. Cosine is adjacent over hypotenuse 1/2. That's the way I should have done it. Okay, but that's sine and cosine. So we're in the first quadrant. Everything's positive. So my cosine is 1/2. So I would do 1/2 I. And in linear combination, there's going to be a plus there. So you're going to have this space to fill in. The computer's going to have the I and going to have the plus. You're going to have to fill this space in by the j. Okay. So then your sine is square root of 3 over 2. And you just put that in. And then depending on which quadrant you're in, you know, your signs may change on that. So let me find another one of those. And again, these, you're being asked for a vector for the given direction angle. So you want a vector for given direction angle. Okay, so they'll give you a direction angle like here theta is pi over 2. And you're asked to sketch it. So pi over 2, guys, is straight up. This is pi over 2. It's 90 degrees. Pi over 2 is 90 degrees, so it's straight up. So its cosine is 0 because it doesn't go left or right any, and its sine is 1. Okay? So if I wanted the vector form, I want it in a linear combination. So it would be 0i plus 1j. So it would just wind up being 1j. Okay. Then another one like this, 4 pi over 3. Again, we want the vector for the given direction angle. So if I do 4 pi over 3, so I can figure out correctly how to graph it, 3 goes into 180 and leaves a 60, so it's 240. So this is my 240 degree angle. So that means I'm here. If I sketch it, I'm here. That's 240. I'm in the third quadrant. So again, I want cosine and I want sine of 240, so I have to know its reference angle. So 180 or 240 minus 180 to get the reference angle is 60. And cosine is negative, sine is negative in third quadrant. So both of them are negative. So the cosine of 60 was 1/2, right? We did it. We did it over there. Cosine of 60 is 1/2. So that means I've got negative 1/2 I. Then the sine of 60 was a square root of 3 over 2, so minus square root of 3 over 2, because they're both negative because you are in the third quadrant where both sine and cosine are negative. So there is your I and your j. If you wanted component form, it'd be -1/2 comma negative square root of 3 over 2. If you're asked for component form. I think it usually asks for linear form, and it might ask for both, but there you go. There's linear, combo, and then component form for both of those if they ask that, okay? Then we want to find the direction angle. Oh, you know what? Let me do one more of these. Let me do one more where we want the vector for the given angle. Vector for direction angle. And then I'll go on to where we're finding the direction angle. Okay, so vector for direction angle. This is 2 pi over 3. So again, we're asked to graph it first. So I want to get rid of the pi's. That's 60. So that's 120. So my angle is 120. So to graph that angle, that means I'm in the second quadrant. So you need to pick the graph where it shows the terminal side in the second quadrant. Again, my reference angle is 60. So again, sine for 60, square root of 3 over 2. Cosine for 60, 1/2. And in the second quadrant, sine is positive, cosine is negative. Not negative, cosine is negative. Okay? Sine is positive, cosine is negative. So for this, we would have -1/2 I plus square root of 3 over 2 j, or -1/2 comma square root of 3 over 2 in component form. Okay, now to finding the direction vectors. The direction angle, not the vector. The direction angle. So the direction angle, let's see. So we could have u is -3/5. The direction angle, you're going to do your inverse tangent of y over x. So we're going to do inverse tangent of 5 over 3. No signs. Don't use signs. So then I do second tangent of 5 over 3. And that gives me about 59. Now, that's not a 59-degree angle. That's not the direction for that. Why? Because that's in the third quadrant. Why is it in the third quadrant? Because it's left 3 down 5. So I'm here. So I want this whole angle. So this is 180. So I've got to add 59 so I get it into the correct quadrant. So your angle of direction, or your direction angle there, is 239. It would help if I could add 239. Okay? So then if we have another direction angle, say t is 2,7, so we do an inverse tangent of 7 over 2. So second tangent 7 over 2 gives me about 74. Now, graph it and make sure you're in the right quadrant. Make sure it can be that 74. So right 2 up 7, we're in the first quadrant. That's between 0 and 90. So that's my angle. That's my angle of direction, or my direction angle given the vector. So they give me the vector, I find the direction angle. When they give me the direction angle, I'm finding the vector. I'm finding the sine and cosine of the vector, okay, for the vector. Okay, then we're going to have to do two things given a vector. So let's see. This vector is negative square root of 3 over 6 and 1/6. So that's my vector. That's vector v. I want the magnitude and the angle of direction for this vector. Magnitude and the angle of direction. So magnitude, it's square root of 3 over 6 squared plus 1 over 6 squared. So square root of 3 squared is 3, 6 squared is 36. 1 squared is 1, 6 squared is 36. So that would be the square root of 4 over 36, which would be 2 over 6, or 1/3. There's your magnitude. You leave it as 1/3. Now we want the direction angle. So do the direction angle just like we've done before. Inverse tangent of y, which is 1/6, over square root of 3 over 6. Do not use the sign. Do not use the sign. So let me show you how you'd put this on your calculator. So you do second tangent first. Then I would put parentheses around the 1/6, then divided by square root of 3. That's divided by 6. Okay, so I've got this. Inverse tangent of 1/6 over square root of 3 over 6. Looks like that on the calculator. And then hit enter. Oh, you know what? Yep, that's not going to work. We need parentheses around this denominator. Yes, I knew I was leaving something out. So I'm glad I sat there and stared at it for a minute because there we go. Okay. So now we've got parentheses around the numerator, the 1/6 parentheses, so that the calculator knows do the 1/6, do this division, then divide, then take the inverse tangent. So then your angle is 30. This is 30. Now that's a reference angle because if I look at this, when I graph it, I'm left and up. So I'm in the second quadrant. Well, 30 is not in the second quadrant. So 30 is my reference angle, so I do 180 minus 30 and get 150. So this angle is 150. That's the angle of direction. Your magnitude was 1/3, that's your magnitude, and then your angle of direction is 150. Okay, so be careful with that. You got to make sure you find your correct angle of direction. Let me see if I can find another one of those. Yeah, that's a good one. Okay, so let's see. I've got this vector, -2, -5. I want the magnitude, and I want the angle of direction, or the direction angle. You'll see it both ways. You'll see it both ways. You'll see angle of direction, and then you'll see direction angle, and you want the magnitude. So square root of 2 squared plus 5 squared, that's the square root of 29, which doesn't simplify any. So there's your magnitude. Then to find the direction angle, you do inverse tangent of y over x, which is 5 over 2, no signs. And then you get that on your calculator. Second tangent, 5 over 2, gives you about 68. Gives you about 68. Now we've got to figure out, am I in the first quadrant? No, I'm not, because it's left 2 down 5. So I'm in the third quadrant, right there. So this is 180 plus 68, because this part right here is 68, which would give you 248. Then you could also see it in linear combination form, where you've got I plus 2j. You might want the magnitude, so it would be 1 squared plus 2 squared, because there's a 1 in front of that I, so that would be the square root of 5. Then to find your angle, it'd be inverse tangent of 2 over 1, which comes out to be about 63. And since this is 1, 2, if I graph it, I'm right 1 up 2. I'm in the first quadrant. So 63 is my angle of direction. There's my magnitude. There's my angle of direction. If you see it, when you see it in linear combo form. Let me do one more with weird numbers in it. Let's see, -1/2, square root of 3 over 2. So we want the magnitude, square root of 1/2 squared, plus square root of 3 over 2 squared. So this is 1/4. This is 3 over 4, which is 4 over 4, which is 1. So the square root of 1 is 1. So there's your magnitude. There's the magnitude right there. Then we want to do the inverse tangent so we can find the angle of direction, square root of 3 over 2, divided by 1/2. Don't use the sign. So second tangent. So again, parentheses everywhere. So square root of 3 over 2, whoops, divided by 2, close parentheses, divided by parentheses, 1 divided by 2, parentheses, 60. So this angle is 60. Now, where am I? It's left and up. So 60 degrees, so 180 minus 60 would be 120. So there's my angle of direction because I'm here. So your magnitude is 1, your angle of direction is 120. And then let's see. Okay, now we want to find the angle between two vectors. And it's just a formula. Okay, angle between two vectors. This is where you do the dot product over magnitude of the first one times the magnitude of the second one. So dot product, x1 times x2 plus y1 times y2, all divided by, actually, it's the inverse cosine of all of that, because we have to find the angle. So it's the inverse cosine of the dot product over the magnitude of the first one times the magnitude of the second one. And then this would be like, well, it's just magnitude. It's square root of x squared plus y squared times square root of x squared plus y squared. So that's how you find the dot product between two vectors. So let me show you. Let's do two vectors. 8, 7 and 9, 9. So I do the dot product. 8 times 9 plus 7 times 9 over square root of 8 squared plus 7 squared times square root of 9 squared plus 9 squared. And it's the inverse cosine of that. Okay, so what I would do is I would put it in just like that in my calculator, except for I would probably go ahead and put, what is that, 72 and 63 in there. So second cosine, open a set of parentheses, second cosine, open another set of parentheses, so 72 plus 63. Close that parentheses because that's your numerator. Then in the denominator, open parentheses, put in second square root, 8 squared plus 7 squared, get out from underneath that radical, times square root 9 squared plus 9 squared, get out from underneath that radical, close parentheses twice. And it's actually 3.8. That's the angle between it. That's a very small angle, but that's correct. So that's how you do that dot product. That's how you do the angle between. You use the dot product to find the angle between. So it's that inverse cosine thing. Let's see. Okay. So let me just show you to make sure, because you're going to see, you want to find the unit vector u, and it shows like a cosine theta I plus sine theta j, and they're giving you this negative I plus 4j. It's the same thing we've done. It's like finding that parallel or the vector that has the same direction, okay? So you just need the cosine and sine of this. So you've got to find your magnitude because you need r. This is your r. Remember, cosine is x over r, sine is y over r. So I would do the square root of 1 squared plus 4 squared, which would be the square root of 17. So for my cosine, that's negative 1 over the square root of 17. Which, on this problem, you have to fix it. So it's the square root of 17 over 17 negative I. Plus, then this would be 4 over the square root of 17, because remember, your sine is y over r. Y, which goes with j, over r, which you have to fix this one as well, so multiply top and bottom by the square root of 17. So that's what that would look like. Okay, then there's another one like that. Yeah, if you're asked for parallel vectors, so I've got 8, negative 6. This is a parallel vector, so it's what we just did. You've got to find the magnitude, which is r, and you're going to put x over r and y over r. So square root of 8 squared plus 6 squared, which is square root of 100, which is 10. So if I wanted cosine, it would be 8 over 10, which is 4 over 5 when I reduce it. If I wanted sine, it would be negative 6 over 10, which is negative 3 over 5. So if I wanted that linear combo, I just put an I and a J by them if I wanted linear combo. If I wanted component form, that's component form. Okay, then you're gonna have something like this, and you're supposed to sketch them to show they have the same direction. Well, I would do y over x on both of them. It's 12 over negative 4, which is negative 3, and then 3 over negative 1, which is negative 3. And guys, that's a slope. That's your slope. So left 1, sorry, left, there we go. Down 3, up 1. Or you could see it as left, oh my gosh. It'd be real nice if I could do this right. Down 3, left. Down 3, right 1. Oh my, because it's negative 3 over 1. That's down 3, right 1. Or you could see it as left 1, up 3. So just look for one of those options. Down 3, right 1, or left 1, up 3 would give you the same graph. It would look something like this. You know, if you went down 1, right 3, it'd look like this. And then if you went left 1, up 3, well, sort of like that. But that's what you're looking at. That's what I would look at, are the slopes on that. Okay, then the last one I want to show you is you're given a vector A to B, which gives us a direction. A is the initial point, B is the terminal point. That's important. That's 6i minus j. And then A is 2, 6. And we want B. We want the coordinates for B. So this AB component form is actually 6, negative 1. So if you remember the very first ones we did where we subtracted the x's to get the component form and then subtracted the y's to get the component form, we've got to do that backwards. So if I want B, if I want the x for B, that means it was x minus 2. Hold on. Right, that means it was x minus 2 equals 6. It was x minus 2, because this is the x and the y for B. It was x minus 2 equals 6, equals that 6. So if I add 2, x is going to be 8 for B. Then for y, it would be y minus 6 equals negative 1. Y minus 6 equals negative 1. Then you add 6. So y is 5. So B would be 8, 5. This is 8.6 again. It is due 4/21. I don't think it opens up. It doesn't open up until Wednesday at 10:45. At 10:25, just like class time. But it's due the 21st. Remember, you've got test 8.3 due and review 8.3 due on Friday. And then this is the only other thing, and it's due Tuesday. So there you go.